All right, so the next section that we're going to move on to in this chapter is now going to be section C, and that is going to be Venn diagrams. And remember, throughout all of the videos that we watch, throughout every single unit that we do, we're always going to have essential questions that we want to focus on. And now this one, for this video, and a new one that we're adding is going to be, how can we represent groups of numbers? Right? The essential question that we were doing before is, how can we define large groups of numbers? And now we're going to do, how can we represent them? Right? We already learned one way in the last section, and now we're going to learn a second way using Venn diagrams. Right? And this section is going to be broken up into a couple of different videos. Right, before we can start solving any questions or really talking about Venn diagrams, there's a lot of key terms that we had to define first. And the first one that we're going to define is the universal set. And the universal set is denoted by the letter U, and it represents all of the elements under consideration. So if you think about one of the first sets that we learned about in the first video was the set of all vowels, A, E, I, O, and U. Well, the universe, we would say, is all of the letters. So the universe would be all of the letters that we possibly have in our alphabet, A, B, C, and so on to the letter Z. So the universe is all of the elements under consideration, meaning all of the letters that we have, whereas the set that we were focused on was just the vowels in that case. So we needed to know what the universal set was before we start to do any Venn diagrams, because Venn diagrams are representing sets or elements by just using symbols. And one of the first symbols that we need to know is a rectangle, right? And a rectangle is part of our Venn diagram, and that represents our universal set. So this rectangle tells us it's all of the elements under consideration, or all of the possible elements that we can have, right? And that is our universal set. So if you want to, you don't have to necessarily write the U there, because it's always understood that that is our universal set. Now within this rectangle, we can draw other symbols, and we can draw circles. Now circles represents any sets that are within that universe, and we can write what we denote that set. So in this case, if we're talking about this universe, we can say that this set V is all of our vowels, A, E, I, O, and U. And then on the outside here of the universe, we still have all the elements A, B, C, D, F, and to Z that are part of our universe but not part of our set. All right, so a Venn diagram is a drawing that consists of a rectangle, which represents our universe set, and then we have our sets inside of it that we represent by circles, like we just did here. All right, so we use these Venn diagrams to answer questions, like we're going to in a couple sections. But we also, it's another way for us to represent our groups of numbers, or a way for us to present our information. All right, now before we start learning any more about the Venn diagrams, there's a few more key terms that we do have to learn. The first of which is going to be the complement of a set. So if I tell you that we have a set A, the way that we denote its complement is with A and then an apostrophe. All right, so that lets us know it's a complement. And what a complement is, it's all of the elements that are not part of set A, but are still part of our universe. So if I tell you that my universe is equal to the set 1, 2, 3, 4, and then I tell you that my set A is equal to 1, 3, and 4, well, the complement to A, it's all of the elements that are still part of our universe, but are not in our set A. So since 1, 3, and 4 are part of our set A, the only element that's in our universe that's not in set A would be that element 2. All right, so remember, a complement is anything that's in our universe, but not part of our set. So before we move on to our next key term, let's just go over a couple questions with the complement. So here it tells us that our universe is a set of all x's such that x is less than or equal to 12, where x are only positive integers. So we know that the only numbers that are part of our universe are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and 12. All right, so those are all the numbers that we can possibly have. So if we want to find a complement to our set A, which is all of our even numbers, that will have to be all of our odd numbers then, because 2, 4, 6, 8, 10, and 12 are all part of the set A. So the complement will be 1, 3, 5, 7, 9, and 11. All right, so now the complement to set B, and the complement to set B says it's the prime numbers in the universe. So the set B talks about all the prime numbers. I'm going to change the color. All the prime numbers in our universe. Well, the prime numbers are numbers that have the only factors are 1 and itself. So all of the prime numbers in this universal set are 2 because its factors are 1 and itself, 1 and 2. 3 because its factors are itself, 1 and 3. 5, 7, and 11. Right? So those are all prime numbers. So the complement to that would then be 1, 4, 6, 8, 9, 10, and 12. Right? 1 is not considered a prime number, so that will be in our complement to this set here. Right, so now the next definition or key term that we need to know is a subset. Right, so a subset, let me just go through an example and then we'll go through the definition. If I tell you that set A is equal to A and B, and then I tell you that set B is equal to A, B, C, and D, well, A, B, C, and D. Well, in order for a set to be a subset of the other, every single element in that set has to be an element of the other set as well. So A and B are sets of A, and A and B are within our set B. So we would then say that A is a subset of B. We can't say that B is a subset of A because B contains the elements C and D that are not in set A. So A is a subset of B if every element of A is also an element of B. And then the symbol that we use is this symbol here. That lets us know that it is a subset of another set. So every single element is also contained in that. So any set that we use or any set that we're dealing with will always be a subset of the universal set. All right, now the next key term that we have to talk about now is an empty set. And then set is empty if it has no elements, right? And the way that we represent an empty set is this symbol here, or we can draw the set notation, but we just don't put anything in it. All right, so let's just go through an empty set real quick then. So if I tell you that our universe is equal to the set 1, 2, 3, and 4, and then I tell you that our set A is equal to 1, 2, 3, and 4, and I ask you to find our A complement, well, since every single element that's in A is in our element U and there's no extra, there would be no elements in our set, our A complement. It would be in an empty set, so you can either denote it by saying the braces and with nothing inside of it, or you can say that our A complement is an empty set. All right, so it just means that there's no elements within it. There's no elements within that set. All right, so there's one more thing that we're going to do with this video, and then we're done with this video. All right, the last thing I want to do real quick is I wanted to just draw a Venn diagram of our number systems that we've learned about. Now, in the very first video, I showed you one like this, but we're just going to draw it ourselves now. So in this Venn diagram, our universe would be our real numbers, right? Any number within this is a real number. So we can then go ahead and say, well, within our real number, we have our natural numbers. And we know that every single natural number is part of an integer. So we can then draw here, I'll change the color, and we can say then that this is our integer set. All right, and then from there, we know that we have our rational set of numbers. So we can then draw our another set within here. And we know that every single natural number is an integer, and every single natural and integer is part of our rational set of numbers. And then on the outside here, you can either draw another circle to denote the set, or since it's still part of our real numbers, but not part of our, any of these, out here it would be our irrational numbers. All right, any irrational number would be still part of our real number system, but would not be one of these. So the circles are representing the sets, and we can then say that our natural numbers are a subset of our integers. We can say that our integers are a subset of our rational numbers, and so on. All right, so this is just one way that you might see or might be asked to produce a Venn diagram dealing with our number system. And we would draw it this way because Every single natural number is an integer, so we would have to draw that set within our integer set. And every single natural and integer is part of our rational number, so we would have to draw that within our set of our rational numbers. And then on the outside here, we still have irrational numbers, which are our pi's, our square roots, 2's, and etc. Numbers that are non-repeating and non-terminating. All right, that is it for this video, and there's a couple more that you will watch for this section.